Look at any distant point in the sky, and you'll see it moving away. The universe is expanding, stretching outward in all directions simultaneously. Because of this relentless expansion, the physical distance between galaxy clusters is continuously increasing. Deep space is actively hollowing out, creating an increasingly cold and isolated void. But right in our own cosmic backyard, we see the exact opposite. The Andromeda galaxy is actively creeping toward us. Astronomers predict that our Milky Way and Andromeda are on a direct collision course, set to smash into each other in roughly 5 billion years. If the very fabric of space is supposedly pulling everything apart, how is it physically possible for two massive galaxies to crash into each other? The answer comes down to a constant, invisible mechanical competition between two fundamental forces: the outward stretch of expanding space versus the inward pull of mass. As 2 points move apart, their gravitational bond rapidly decays. Take NGC 3370, a galaxy 100 million light-years away. The Milky Way still pulls on it, but every inch of that space is expanding, accumulating into a massive outward push. That accumulated push easily overpowers the weakened gravitational pull of the Milky Way. As a result, NGC 3370 is actively receding from our galaxy. On a macrocosmic scale, sheer distance guarantees that the outward force of cosmic expansion will always defeat gravity. Our local group contains 80 tightly packed galaxies. At this smaller scale, the Milky Way and Andromeda's immense mass creates an overwhelming gravitational bond. Because there is less physical space to expand, this localized attraction easily defeats the outward push of cosmic expansion. Because gravity is the dominant force in this pocket of the universe, the physical space between the two galaxies isn't stretching, it is actively shrinking. Universal cosmic expansion is a background condition. It applies everywhere, but it can be locally conquered by sufficient mass and close proximity. Because of this localized gravitational victory, astronomers have treated the Milky Way-Andromeda collision as an absolute certainty for decades. But a paper published in the June 2025 issue of Nature Astronomy challenges that long-held conclusion. The researchers pointed out a flaw in the previous predictive models. Those older calculations treated the Milky Way and Andromeda as if they existed in total isolation, completely ignoring the gravitational weight of the other 80 galaxies inside the local group. When you add those missing galaxies back into the math, the gravitational pull from these nearby bodies introduces unpredictable variables, bending and warping Andromeda's trajectory. By factoring in these interactions, the expected direct impact might actually turn into a near miss. The universe operates as a fractured battlefield. The macro expansion of deep space and the microgravity of local clusters create highly varied environments with entirely different physical outcomes. The universe at large is steadily expanding towards isolated darkness. Yet, right here in our localized pocket of high mass, the environment remains chaotic, dynamic, and capable of rewriting its own cosmic fate.